I have been doing the BIOS for many, many years, right? More than 20 years. So I was in charge of the biggest BIOS company kernel, that's the Phoenix BIOS and Award BIOS. So I know how when your product ships like in a large scale, how important you have a stable kernel so you can maintain, you can get out the patch. And sometimes you cannot believe it, like a little change in your kernel, you can disturb the whole world. And so today I'm mainly talking about how we do open source firmware. And my emphasis is community driven, because open source is actually not a big deal. That I remember when I started the BIOS is the IBM PC. Surprisingly, it's totally open source. IBM PC, you bought it, you have two menus. The second menu and half of it is BIOS source code printed, right? But that's not community-driven open source, it's pattern. So we want makes the firmware develop more like the Linux OS develop. It's complete open source, and it's driven by the community, right? So far, we see a lot of open source is donated by large corporations, right? So they have a plan, what is our BIOS lookout, and they did everything, and anybody participate and make minor changes. They are not actually changing the direction. And, but the industry was going is the hardware guys make the firmware and they give it to the open source world. But in reality, what we want is application driven. From the application goes down to the OS, and then you define a firmware structure, architecture, and then you fit the firmware for different hardware. So different hardware can contribute. And to propose this, I have some basic consideration. First, that we really shouldn't focus our firmware in it's only for the server, only for ARM. It should be multi-architect and for all kinds of different products, like Linux, right? It works for everything. So, and then we need to support multiple OS. Before here, Linux, we all Linux guy, we don't like Windows, but I think for firmware, we want to support Windows or whatever the new OS is. And we are not, we are ARM-centric, but we are not ARM only, right? We will support all the firmwares, and we encourage new silicon being developed and supported. The key point here is, first, is community-driven. So my proposal is we are not giving out a complete open source project, but we set up rules that people can drive it. And then we want make sure that we have the positive change to support industry standard like the EDK2 community just did. And they confirmed that now you don't need to wait until the UEFI specification published before you can write the code. You can write the code and when the people define the specification. And we hope that PCIe will change like that. So everything should be the code first finding model, right? So that's the. And for the license, I will prefer to use this permissive free software license. So it has a little bit flexibility for the silicon vendors. And the short-term goal is we want a long-term stable label, which is manageable for the customer. And there's a lot of open source guys say, okay, we want to found a PC and try to make use open source booted. This is not our goal. We don't want to reverse engineer. You know, we respect other people's IP, and we do not force to use TPL license. So if you want to keep your binary, that's fine, right? And I just want to make sure I have enough time. And we know that the firmware usually has 3 components. It's the kernel and the silicon and the platform. The kernel part is like a generic framework, a standard library, and it's very easy to make it open source. But on the silicon side, you know, every company wants to keep their distinguished or competitive advantage. So sometimes it's hard, but some standard silicon software should be open source. So we will push as open as much as possible. But for the platform, you know, like ACPI, it's all visible. So I don't see anything like you don't want to open source. We should make them all open source. But some advanced feature, like the RAS feature, you know, there's vendor-specific hardware, and it may not be open source. That's also possible. But so the end is when we do the open source, my suggestion is we need to have an ecosystem which is benefit for everybody. If someone don't have a benefit, they will not contribute in the ecosystem, and then the ecosystem is not a perfect ecosystem, right? So we don't drive the IBV out of business, and they can provide service, right? And we want silicon vendors, new silicon vendors can make new device and contribute into the system. And of course, the cloud and software service vendors, OS vendors, all benefit from the ecosystem and willing to participate. That's very important. So what we talk here for the firmware, the special thing is how to protect the silicon vendor's IP, and for most stuff, the member company here in Linaro is a silicon vendor, and they want to protect their IP. At least they have a few years competitive advantage. And open source is originally driven by the big cloud vendor, because they don't sell hardware, right? Open source is really good for them. But due to the hardware, and there's some compatibility, like the memory controller, it's really, people really don't want open source, those things. But even it's open source, we don't have the time to understand it or to change it. So in the EDK implementation, and they have separate different directories for the kernel and the silicon, and so the silicon can be delivered in binary. I think that will be fine. So for Linaro, I think it will be, as a software company, we probably more focused on the kernel side, not on the silicon side. But we will define a standard silicon interface. And it will be nice that we can do the software emulation and have some emulated hardwares included. That will be very nice, like the serial the serial part. Those things, that's no secret, right? So, and about the software license, the BDS license is preferred, like proposed by the EDK2 or the trust firmware.
BDS license?
BSD. Or BSD.
That makes more sense.
Yeah. I need to correct. Yeah. So then we want to know. This is my personal experience. If you go out talk to custom, nobody want to update their code to the latest. if they are shipping a product. So some product, they use very old, you cannot believe. Even Linux is the same situation. So we want to maintain this code and such that we are able to give security patches. I think I already write most of the thing, and we already see that, for example, in the EDK implementation, and we have a quarterly release, which is relatively stable, and but we want to let the customer know there's some release is very stable, and there's some people to do the maintenance. Or maybe a commercial companies like IBM will do the maintenance, give the security update, right? So in this way, I think if all the different hardware vendors, software vendors, system vendors use the same kernel, like Linux kernel, then it will benefit the whole industry. And once when you have a stable code and you want to have a standard interface, the code, the interface will be interfaced to silicon module. But we, in the history, we have many interfaces like Intel's IFWI, FSP, that the firmware support package. One of my friends, he created to promote Intel's CPU into the embedded world, right? And ARM, we have PSAI, all kind of a standard. This standard, I think it has a relative short life cycles, and they're vendor specific. But if we can have a standard more like the industry standard, like UEFI, where all the company work together, ACPI, that will be definitely better. But I don't have a good solution there, just suggestion. So this is, I just said all what I think is what we want to do. And I want to introduce you is what industry has been doing. So now in the OCP, I think they just had a meeting right now somewhere in the world. It is the open software, open system firmware group that is headed by Ron Minich. And he was from US Lazarus Lab, that's formed, he's the one made open BIOS at maybe 20 years ago, when I was the one in charge of the closed source code BIOS, right? After 20 years ago, after 20 years, he's famous, and I almost lost my job. So I think open source eventually wins. And before I come here, I went to the very successful open source firmware conference, where people present all kinds of open source solutions. And obviously, the most widely used is U-Boot, and these support numerous architect and platforms, and use all kinds of language. I just realized there are so many language, CPU, computing languages used, and even Go, Rust, those things, it can be used in the firmware. So, but because it's diversity, it's really hard to, I think, to use U-Boot as a standard one, right? Because people can, and the Coreboot is a little bit better, and it's more extensible, and has a very good open source environment. So Facebook has used this. I think Jonathan is the one did this presentation. He used to work with KVM here on the firmware, and they use Coreboot and use LinuxBoot as the payload and to support all kind of device. It looks like they are getting there, and they actually work with the ODM in Taiwan to implement features by feature. I think it take maybe another year or 2 years before they can have all the server feature in. Right? That's a problem. We want it today. And so you see that LinuxBoot become kind of hot words, but LinuxBoot is actually pretty simple. You put a small Linux kernel into your firmware. So before you boot to the disk, you are already in the Linux. So the argument is there's much more people in this world knows Linux, so they can play around. And it turned out it's true that during the conference, some interns from work for Google did something very interesting, and they actually worked on the Linux kernel to boot Windows 10, right? And then another group, and they boot from the Linux kernel, they boot web OS. So they download the OS image from web and boot. And all those people did all those things from a short summer intern period, a few months. Of course, those people are, I think, very smart. But I think we are more focused on deliver a real product. So on the next section, I will more focus on how we deliver a real product. It will, if you look at all the firmware, they all staged, right? Like the RAM stage, ROM stage, RAM stage, right? But Intel recently proposed the mini platform approach, and they divide it into more different stages, right? For example, this, like you have the memory functional stage, UEFI boot shell stage, and security stage. I'm not, but they are not community driven. They give us specs and they release the source code. And we are waiting for the next release. We don't know when, right? So, but the idea is good. So we, as UEFI, I think a lot of people we have a very big framework. If we can actually make the framework staged, so you can use a small framework and then add on, so the framework become bigger, will be very interesting. For example, the Dixie framework, right, and the PEI framework can be separate. Sometimes a device only need a PEI, they don't need Dixie. And in the reality that people claim they have open source firmware, they are not, right? They have a memory controller sitting there, it's complete closed source, and in most of the Intel platforms, they have management unit. Right. In ARM, we have this SCP, MCP stuff, and this usually a real-time software system. So the open source actually has way to go. BMC is pretty much open source that in OCP, but how about FPGA, GPU, those things, right? So there's a process. We should be adapt all those things together, but our CPU firmware is the call to adapt all those things. Once you go through the CPU open source firmware, you can use, we try to use all kinds of tools. For example, the UEFI tool and maybe the OS tools to debug and configure. Right? Then we can have different payload. Linux kernel, like LinuxBoot, is one kind of payload or other payload. Just firmware, ACPI, these kind of things. So Another complaint about UEFI code is like it's not boot fast. But I think that's an excuse because UEFI has the flexibility. You know, if they found the driver dependency through many runs, so it's slowed down. But once you boot once, you know the dependence. You actually can, next time you boot, just straight. And then we also have a method to only initialize the device who is needed for boot. So leave all the PCI devices which is not needed for boot, not initialized. So there's many ways. So my notebook actually can boot 2 seconds to window, right? So it's not slow. So it's possible. It's just the way how you do it, because at the end, a system boot needs that much code, no matter how you do it. It's all achievable. And as we see, it's a heterogeneous system, so we need to accommodate all kind of non-UEFI module. I will see is actually just the firmware is not necessarily a UEFI module, right? Since it needs to be connected in the server system, also in the like a phone system. Even Intel's FSP is not a UEFI module. Internally it's UEFI, but the interface is not a UEFI module. So, and a lot of runtime service are not necessary. The MM service are not necessarily UEFI compliant. But I see a good chance, for example, in Intel's FSP 2.1, actually, if I want to fit in a UEFI framework, they also provide kind of a PI standard interface to it. So anyway, the point is we want to use a standard interface, not a vendor-specific interface to integrate with the UEFI framework. And about the tools, we already have, where is it? We have a lot of tools in OS. And a very interesting effort is from Intel. They actually publish a paper and try to use this OS-based tools, and it looks like it's successful. So they can check, test the firmware, check the integrity, and so the same way, if you use Linux, you can boot to Windows. You use UEFI, you probably still can use the OS tools. Yeah, as long as you are not limited the way you are thinking. So at the end, we want to use all kinds of tools to make it work. It's popular test tool, the SCT has been used for years in UEFI world, and the FWTS has been used many years in the Linux world. And ARM recently promoted this dynamic table framework to generate ACPI tables, right? And SM BIOS table, I think that is very useful. Actually, those kind of things, we did it many years ago when ACPI come out, but nobody maintained it. But if open source, we have a maintainer that will be good. And they also have tools for ACPI view. So if you have a binary, you can run that to see the ACPI configuration. That's very useful. So in summary, that we know that open source is a chance, and we want to do it, and I want to do it in a community-driven thing. So I just give suggestions how we should do it, and let the community to decide what we do. So first is that we want to support multi-architect, and we support all kind of silicon vendors. So the goal is not server only, and actually I want to do is server, and then maybe desktop, then phone, and maybe IoT in the future. But we want leverage what we have invested in the past in LDCG here. We have invested on SPSA QEMU. They have a presentation in the last year's Connect, and we have the SPSA QEMU firmware prototype and the test suite, and we also actively participate in the EDK2 mentorship, right? So we base on this, and we can do our work. And my suggestion is not from zero build up like the Coreboot or those people, but we from a working system, we take out the module, replace some module, reduce it. Finally, it can go reduce to very small things. So the first thing is let's set a base. Anything do, like you have a baseline, so we want a stable label. And then we can remove the server package, right? So once you remove the server package, you can install a desktop package to working on the ARM desktop. I really think ARM is still missing one thing is ARM notebook. I would like to see one day there's a ARM-based notebook running Linux. And we needed to very closely work with the UEFI community, ACPR group, ACPR, and ARM Trust Firmware sake, right? So this component can be seamlessly integrated with the system firmware. And same as Linux, we want to be able to build this UEFI kernel with the teeny little size, or medium size, or large size. And everything should be possible. That's pretty much that my proposal is, and I hope that once we set up this project, many people can join us to work on a real community-driven firmware. Thank you.